Okay, what we're going to do is go through some additional problems on how to find multiple solutions when given a b-value other than 1. So once again, when you have a b-value other than 1, chances are you're going to have a lot of different solutions on an interval from 0 to 2 pi. All right, and that's what we're looking for is we're trying to find solutions on the interval 0 to 2 pi. And what we have is this trig function, and we're going to do without our calculator. And so with that, and the first thing is that we solve for the trig function, which is already solved for. Next thing is we're going to take the inverse sine to solve for the inside. So 2x is going to equal the inverse sine of negative square root of 3 over 2. And that's what we have right there. Now, from here, we know that sine is negative in these two quadrants right there. So here and here, okay? And so what we also know is that we have the opposite, which is square root of 3, and here is 2, and over there it's going to be negative square root of 3 over 2. And so what reference angle is this going to be? Well, this should be pi over 3, which is a 60-degree angle. But since we're in the third quadrant, that's going to be 4 pi over 3. We can go all the way around here. And we also know that we have then also 5 pi over 3. 5 pi over 3 is our other one, and that's in the first, all right, the fourth quadrant. So here's our third quadrant. Here's our fourth quadrant angles. And so we're going to write those out. So we have 2x, and that's going to equal 4 pi over 3. Okay, now we're going to do this because since we have a b value that we know we're going to have additional values, we're going to go adding, we're going to add 2 pi n, all right, our coterminals, okay? So because we have multiple angles, b value greater than 1, all right, multiple angles, we're going to use our coterminal. Use coterminal. Use coterminal. And I'm just going to put a little arrow right there just so you can see. So now from here, we're going to solve this. When we solve this, we're going to divide by 2. All right, for this first one, oh, we probably should make the other one. So we have another one over here on this side. 2x equals 5 pi over 3 plus 2 pi n. Okay, so now we're going to divide by 2. When we divide by 2, what we'll have is 4 pi divided by 6 plus 2 pi n divided by 2, which will just turn into pi n. Same thing happens over here. We have 5 pi over 6 plus 2 pi n divided by 2. And so now from here, remember, now we're going to find all our angles. So once we have this, we're going to find, all right, all solutions on interval 0 to 2 pi. All right. Now, if you think about this, this is our bottom. So 2 pi is actually going to be, if we think about this, 0 to, well, let's have a multiple of 6, would be 12 pi over 6. And that actually equals 2 pi. I'm just going to make that so these are the same denominators when we're doing that. Okay, so now from here, we're going to find our additional values, okay? And so what we can do is we can just say, okay, when n equals 1, what are our different values going to equal? Okay, or actually when n equals 0, we'll say when n equals 1, when n equals 2, and we'll just keep on going down until we get to our end. So right here, when we plug in 0, we have 0 right here, and we have 4 pi, so x is going to equal, all right, 4 pi over 6, and also it's going to equal 5 pi over 6. Okay, so 5 pi over 6, all right, and that's our first two solutions, okay, and then we have when n equals 1. When n equals 1, we're going to have 6 over 6, so this is going to be 10, right, 10 pi over 6, 10 pi over 6, because now we're plugging 1 into here. Okay, and we probably want to change this into 6 over 6. We'll change this over 6 over 6 as well, just so we have a common denominator. Makes it a little bit easier. And we plug a 1 into here. All right, 1 into here. We have 11 pi over 6. 11 pi over 6. You can see a pattern forming now. Next one, we're putting a 2 into here, 2 into there. Okay, so remember we're putting a 2. So this is where we have, just put this in. So each one of these, just so everybody knows, when we plug these values, we're going to plug them into here and into here. That's how I'm getting these new values here. So 2 would be 12. 12 is going to be 16. I'll put back red. It's going to be 16 and 16 pi over 6. And when you see this, okay, so n equaling 2, 2 is going to be 12. 12 plus 4 is 16. 16 pi over 6. Well, right there, that is too big, all right? And because it goes past, we're only asked to go up to 12 pi over 6. This is 11 pi over 6. We probably should have stopped there. And so we are done with all of our answers. There's 4 solutions right there. And those are our 4 solutions that we have. Okay? Well, that is how we solve this problem. All right. You can verify this on your calculator if you want to. All right. So if you want to pause this and look on your calculator. So if you put this in your calculator, we are going to have this right here. Okay. Once again, we're taking sine of 2x, negative square root of 3 over 2. That is what we're trying to solve it to. Make sure you check your window. Once again, from 0 to 2 pi, I put pi over 12 right here. I put negative 2 and 2 in my calculator. And then we're going to go and graph this. And we're going to see how many different solutions are we going to have here. Let's see. And we can see 1, 2, 3, 4. You got it. If you just want to test one, just make sure you did it correctly. Press trace. We can just go 4 pi divided by 6. Press enter. And we can see that's going to be the value. All right. Obviously, with all these, we can simplify them if we wish because they are multiples. So if we just want to have our correct solutions, we could just write them as 2 pi over 3, 5 pi over 6. We can simplify this to get a 2, 5 pi over 3. And we also can have 11 pi over 6. And that would be our simplified solutions. Okay? Just put simplify. All right, simplify. There we go. Okay, so hope this helps you out, and we'll have some other problems in just a little bit to make sure you know how to do it.